Hello, welcome to my tutorial, Mixtures Part 2. We call that solutions. A solution is a homogeneous mixture in which one or more substances are dissolved into another substance. So, in the first part, we talked about homogeneous mixtures. In this part, we call solutions, basically a synonym of homogeneous mixtures. And there's always a small part that you dissolve in the large part, but I'll explain that in a few seconds. Examples of solutions are salt and water, a cup of coffee, cleaning products, various creams, even a nice cup of hot chocolate. So, going back to the small part versus large part, the small quantity that is being dissolved, we call that a solute. And it's always the smallest. So example, salt that you dissolve in water, alcohol that you can dissolve in juice or water, and even a gas, carbon dioxide, for example, is dissolved in water to make soda drinks. And there is also sugar, yes. In all of these cases, it's always a smaller quantity that we call a solute. The solute is dissolved into another substance called the solvent. Example, the water. It is always the larger quantity. 99% of the time, water is the solvent. It is the one that dissolves a lot of different solutes. So here's a simple equation to remember. Triple S, the solute added to the solvent will give you a solution. Here's an example for sugared water, a sugar solution. So you'll take, let's say, a spoon of sugar that you dissolve in water. That will give you a sugar solution. Another example would be chocolate milk. Which one is the solute, you think? That's correct, the chocolate. Either chocolate syrup or chocolate powder. And which one's the solvent, you think? Milk. Correct. The two together will give you an excellent morning solution, chocolate milk. Remember, however, that this mixture has a new physical properties, meaning they look different. The chocolate looks different, the milk looks different. It's no longer white, it looks brownish because of the chocolate. But keep in mind that the nature of the substances did not change. It is still milk, it is still chocolate. It's just dissolved. It didn't magically become vanilla. Same with the sugar that you dissolve in water. It is still there, but in a different form. It is dissolved. And you can tell by tasting it. Here's an image of a solute, which is the smaller quantity, that you dissolve in the larger quantity, the solvent. This image explains how sugar molecules dissolve in water. Sugar molecules are red, dissolve, and when they dissolve, they go in between the molecules of water, as you see in this picture. When that happens, we say the sugar is soluble because it is able to dissolve in water. However, sometimes if we add too much sugar, the little red particles here don't have room anymore, so they end up sinking in the bottom of the container. If that's the case, we call that a saturated solution. Here's a picture where the solution is extremely saturated. There is way too much sugar. All of that excess sugar cannot fit in between the water molecules. We call that saturated. To make candy, for instance, you need it to be saturated. A suspension now, and not the one you're thinking about. A suspension consists of a solid substance that is unable to dissolve in water. Sometimes when we mix substances, they can cluster. We therefore say it is insoluble in water. The perfect example for that is chalk and water. As you may know, chalk cannot dissolve in water. So if you do mix powdered chalk into the water, they will lump up, create little clusters of chalk, and stay suspended inside the container until they find their way to the bottom and they become sediment. Same thing what happens in sand. If you mix sand and water together, the sand will stay suspended in the water until it eventually finds its way at the bottom of the container. Liquids can also mix. If two liquids totally mix, we call that miscible. The liquids are miscible. If they are unable to mix, they will be called immiscible. It's just a synonym for liquids that cannot mix, liquids that can mix. And it even sounds like mixable. So miscible sounds like mixable. An example for that is alcohol and water. Or the chocolate syrup previously that dissolved in the milk. When two liquids don't mix, we call that immiscible. And the perfect example is oil and water. The oil will stay on the top of the water because it is less dense. We say emulsion occurs once the oil sits on the top. And that is the end of my tutorial today.